Hello geometry students. Today we are starting topic 9 with 9-1 polygons in the coordinate plane. Your learning targets for today say I will use coordinate geometry to classify triangles and quadrilaterals on the coordinate plane. I will solve problems involving triangles and polygons on the coordinate plane. And our vocabulary is the distance formula, formula de la distancia, midpoint formula, formula del punto medio, slope of a line, pendiente de una recta. Example 1. What formulas can you use to identify properties of figures on the coordinate plane? For example, which formula can you use to find AB? And they mean the distance from A to B. So we will use the distance formula, which is x2 plus x1 squared plus y2 plus y1 squared, and then take the square root. And that is the distance formula. So let's do it. Let's figure out what that distance would be. For the x's, it would be 3. Oh, I'm sorry. We need to change this a little bit. It was minus, not plus. The distance formula is we're subtracting. So I have x1, y1, x2, y2. So x1, or x2 is 3, so 3 minus 1 squared. And y2 is 1, y1 is 6. So 1 minus 6 squared, and we're adding those. 3 minus 1 is 2. 2 squared is 4. 1 minus 6 is negative 5. And if you square that, it becomes positive because it's a negative times a negative. So 2 squared is 4. 5 squared is 25. And so the distance between those two is equal to the square root of 29. And we would use the formula to figure out the bisector of AB. We'd use the midpoint formula. And the midpoint formula is x2 plus x1, it is plus this time, divided by 2, comma, y2 plus y1 over 2. And we will apply that. So x2 is 3, and x1 is 1, divided by 2, and the y's are 1 plus 6, divided by 2. Simplify that, and it's 4 over 2, which reduces to just 2. 4 divided by 2 is 2. 1 plus 6 is 7. 7 divided by 2 is 3.5. When we graph that on our coordinate plane, we go over 2, up 3.5. So that point is right there, and the midpoint bisects the line. That's the definition of midpoint. Why do the slopes of AB and BC show that the measure of angle ABC is 90 degrees? So why is that angle 90 degrees? Right here. It's getting a little bit messy, but we need to figure out the slopes. So we would use the formula for slope, which is the change in y over the change in x. So we subtract the y's, we subtract the x's. Well, then we need to figure out the slope of AB and the slope of BC. And if they're negative reciprocals, then it'll be 90 degrees. So for A to B, it would be a slope of 1 minus 6 and 3 minus 1, which is equal to negative 5 over 2. For BC, we would do 3 minus 1 for our y's and 8 minus 3 for our x's. That becomes 2/5. Are these slopes negative reciprocals? Yes, they are. So the slopes are negative, I'm just going to abbreviate that, negative reciprocals so the lines are perpendicular, which means they're 90 degrees to each other. All right, moving on to example 2. This one's kind of fun. We're classifying a triangle on the coordinate plane. So the vertices of triangle PQR are P 4, 1, Q is 2, 7, and R is 8, 5. So let's graph that. 4, 1 is right here, that's P. 2, 7 is here, that's Q. And R is 8, 5. Connect those to make it a triangle. And then they're asking, is it equilateral, isosceles, or scalene? Equilateral would mean all the sides are equal. Isosceles would be 2 sides equal, and scalene would be no sides are the same. All right, let's figure out this first side, P to Q. So P to Q. What would that distance be? Because that would tell us how long the line is. So the distance formula is x2 minus x1 squared and y2 minus y1 squared. We add them together, take the square root. All right, let's label these x and y. For the x's, 2 minus 4 and 7 minus 1 for the y's. You need to keep the order consistent. Actually, it doesn't matter too much because when you square it, it becomes positive. When you square it, it becomes positive. I'm not going to put the square root on there, just remember it. We're going to take the square root. So this is negative 2 squared is 4. 7 minus 1 is 6. 6 squared is 36. We add those. That equals the square root of 40. And that was from P to Q. The distance from P to Q. Now let's do the distance from Q to R. So this distance. Q to R. Same thing, I'm going to subtract the y's. So 7 minus 5 and 2 minus 8. Oh, I did that in the wrong order. It doesn't matter though because we're adding them. So I did the y's first. In this case, it does not matter. I want to make you have to erase. We'll still get the same answer. So 2 squared and negative 6 squared. Again, this is for Q to R. So that's 4, and this is 36. So we get the square root of 40 again. This side is square root of 40, and this side is square root of 40. All right, is it equilateral? Is P to R the square root of 40 also? Let's see. P to R. Okay, So we're going to start with the x's this time. I messed up last time. So 8 and 4, 5 and 1, the y's. Square them, add them, take the square root. 8 minus 4. 4 squared. 5 minus 1, 4 squared. 16 plus 16. That's 32. Well, the square root of 32 is not the same as the square root of 40. So that would be isosceles. Isosceles, because two sides are equal in measure. Is it a right triangle? I can tell it's not a right triangle. We could figure out the slopes and see if there's a negative reciprocal, but I can tell just by looking at it. No, not right. It's not 90 degrees. Visibly not 90 degrees. That's our explanation. I don't like the way I made my y. Not visibly. Okay, that completes our notes for the first two examples, and then we'll continue with the back side of our notes tomorrow.